Okay, let's take a look at halogen substituted aromatic rings. We're going to find that they are the exception to the rule that activators are always ortho-para-directors and deactivators are meta-directors. So somebody would run the reaction of bromobenzene and compare it to benzene itself. And we found that, well, scientists found that the rate of bromobenzene being reacted with a generic electrophile is slower than that of just benzene. So you see that bromine or other halogens are deactivators. And this is not a huge surprise to us because we know that the C-Br bond is polarized via induction. The bromine or other halogens are pulling electron density out of the ring towards the bromine. So the ring is deactivated as a nucleophile. It does not react as quickly with electrophiles. And so you might say, well, maybe it's got to be a meta-director then. Well, scientists performed that reaction and they found that it is not a meta-director, it's ortho-para-director. So let's go ahead and explore the resonance structures of a para substitution on bromobenzene. I'm going to add a generic chloride or chlorine electrophile like we would get with Cl2 and AlCl3. And let's go ahead, draw some arrows. I'm going to skip ahead and draw the rest of these resonance structures, then we'll come back and discuss them. Okay, so you see I have 4 resonance structures here, and just like with the activators or the deactivators, we put electrophile on the ring, we gain a cation, we can make that move with resonance. We do get an additional resonance structure with the bromine using its lone pair to donate electrons towards the cation. So this is a 4th resonance structure, and it's the same type of resonance structure we'd get with any sort of electron donating group in this position, anything that has a lone pair that can be donated. So we see support for adding our electrophile at the para position. Remember that these resonance structures are identical to those that we get when we add to the ortho position. So this is an ortho-para-director, and that's because we get this 4th resonance structure that we would not get if we added the chlorine to the meta position. And you can draw those resonance structures if you want. You will not get the additional 4th resonance structure. So it shows that while bromine is a deactivator, because we know the rate of the reaction is slower with electrophiles than benzene itself, it's also an ortho-para-director. Same with any other halogen, fluorine, chlorine, iodine, or bromine. Typically, bromine and chlorine are the most common ones that we encounter. So that's why halogens are considered the exception. They are, by induction, electron withdrawing groups, so they do deactivate the ring towards electrophilic aromatic substitution. However, they do have the lone pair that they can donate to this cation here, forming this 4th additional resonance structure, which allows, or which favors the ortho or para addition versus the meta addition. So the halogens are a unique case of substituent on aromatic rings. They are deactivators, but also ortho-para directors.